Good morning to all. Myself, Dr. A.V. Raghavendra Rao, Assistant Professor, Department of Chemical Engineering, BVRAT, Narsapur. Today, I am going to discuss about three important topics: classification of chemical reactions, rate of reaction, and factors affecting the rate of reactions. First, we will see what is chemical reaction. Chemical reaction is a process that involves transformation of one or more substances, that is reactants, into products, resulting in the formation or breaking of chemical bonds. So coming to the classification of chemical reactions, as we see in the classroom also, in the students, if you want to classify the students in the classroom, you can classify them based on the gender, based on their height, based on their marks, based on their age, etc. Similarly, in the same way, we can able to classify the chemical reactions based on the phases, based on the catalyst, based on molecularity, heat effects, and direction. First, coming to the classification based on the phases. Chemical reactions can be classified into mainly two types based on the phases. First one is homogeneous reactions, second one is heterogeneous reactions. In homogeneous reactions, all the reactants and products are in the same phase. That means if you take any chemical reaction, if the reactants and products are in the same phase, that means it may be gas phase reactions or liquid phase. That means all the reactants are in gas phase or all the reactants and products are in the liquid phase. Then it is called homogeneous reactions. The main advantage of these homogeneous reactions is the molecules are readily available in homogeneous reactions. That means if a reaction is happening, say A and B are reacting with each other to form a product. In homogeneous reactions, the molecule A and B are readily available. That means there is no need to search B for A as well as B for A. That means both are readily available to form the products. Unlike in heterogeneous reactions where you have two phases, that means gas phase or solid phase or liquid phase or solid phase, where one phase the molecule is diffused to other phase to react and form the product. That is the most advantage of these homogeneous reactions. So coming to examples, the gas-base homogeneous reaction, the nitrogen oxide decomposes to give nitrogen monoxide and oxygen. You can see here all the reactants and products are in the gas phase only. Similarly, the liquid phase homogeneous reaction, the example you can see the hydrogen HCl reacts with NaOH to form NaCl and water. You can see all the reactants and products are in liquid phase. Coming to heterogeneous reactions, in heterogeneous reactions, the reactants or products are in different phase. That means if one reactant is in solid phase, then the other reactants is maybe in the liquid phase or gas phase. The combinations for heterogeneous reactions are gas liquid, liquid solid, and gas solid. Coming to the example for gas liquid reaction, chlorine gas reacts with water to form hydrochloric acid and hypochlorous acid, which are mainly used in water treatment for disinfection. You can see here the chlorine is a gas phase and water is a liquid phase to form hydrochloric acid and hypochlorous acid. So this is an example for heterogeneous reactions like a gas liquid reaction. The second one is liquid solid reaction. So mainly the leaching of minerals is a very good example for this liquid solid reactions. So you can see example here, the aluminum oxide reacts with NaOH, sodium hydroxide, to form sodium aluminate and water. See, aluminum oxide is solid phase and NaOH is liquid phase and reacting to form sodium aluminate and water. Here the liquid and solid are reacting to form the products. So this is an example for liquid solid heterogeneous reaction. And the third one is gas solid. Example is the combustion of carbon with oxygen. So the carbon is a solid reacting with oxygen gas to form carbon dioxide. The second classification is based on the catalyst. So chemical reactions are classified based on the presence or absence of the catalyst. So you can see here the two categories classifications are catalytic reactions and non-catalytic reactions. A catalyst basically is a substance that increases the rate of a chemical reaction without being consumed. That means it only increases the speed of the reaction. It is not consumed in the reaction. We can able to reuse it, that catalyst. Coming to the catalytic reactions, in catalytic reactions, a catalyst is used to facilitate the reaction. That means the catalyst increases the rate of reaction by providing an alternative pathway with lower activation energy. The example for these catalytic reactions, you can see the hydrogenation of ethylene to form ethane in presence of nickel catalyst. The second classification is non-catalytic reactions. In non-catalytic reactions, no catalyst is used. That means the reaction occurs without aid of any catalyst. The reactants themselves participate in the reaction to form products. The examples for this is nitrogen monoxide reacts with oxygen to form nitrogen dioxide. The third classification is based on the molecularity. So what is molecularity? Means the number of molecules involved in the reaction. That means how many number of molecules collide with themselves to form product. That is called molecularity. So the chemical reactions can be classified based on their molecularity. You can see here mainly three types of reactions: unimolecular reactions, bimolecular reactions, and trimolecular reactions, and sometimes it is called termolecular reactions also. Coming to the unimolecular reactions, mainly molecular decompositions will be examples for these unimolecular reactions. That means here you can see the phosphorus pentachloride decomposes to form phosphorus trichloride and chlorine gas. This is example of unimolecular reactions. That means here one molecule is participating in the reaction to form products. Coming to the bimolecular reactions, it is called molecular combination. That means two molecules combine to form a product. So here hydrogen and chlorine combines to form HCl. So this is example for bimolecular reactions. And coming to trimolecular reactions, that means three molecules involves in the elementary steps. That means the three molecules involves in the chemical reaction to form product. So normally this is very rarely happens because three molecules react to form products is somewhat you can say rarely happens. That means three particles collide simultaneously is somewhat rare. The examples for this is two molecules of SO2 reacts with one molecule of oxygen to form two molecules of SO3. So this example for trimolecular reactions. You can see here unimolecular reactions. This is the example for this one. And in bimolecular reaction, you have two possibilities are there. That means similar type of molecules forms a product, or two other different type of molecules can form the product. In termolecular reaction also, two molecules of same type and one molecule of different types can react themselves to form product, and three different types of molecules can react themselves to form product. So this is based on the molecularity. Coming to the classification based on the heat effects, chemical reactions are classified based on the heat changes associated with them. Coming to the classification based on the heat effects, there are mainly two types of reactions are there. One is exothermic reactions, second one is endothermic reactions. So in exothermic reactions, the heat energy is released to the surroundings. That means when the reaction happens, some heat is evolved. So when this will happen means when the energy required to break the bonds is less than the energy released when new bonds are formed. So when this happens, the energy is released. The example for this exothermic reactions is methane gas reacts with oxygen to form carbon dioxide and water. Along with this one, heat will be released. Coming to the endothermic reactions, in endothermic reactions absorbs heat energy to form for the reaction. That means it takes the energy from the surroundings. The temperature of the surroundings decreases during the reactions. The examples for this endothermic reaction is ethyl alcohol gives ethylene, water, and heat is taken from the surroundings. That means endothermic reactions actually takes energy from the surroundings. The last classification is based on the direction. That means there are two type of reactions are there: reversible reactions and irreversible reactions. In a reversible reaction, the chemical reaction in which the products of the reaction can react with each other to reform the original reactants. That means if A and B are reacting to form C and D, then the same reaction conditions, the C and D can react themselves to form again A and B. That is called reversibility. That means the products again react themselves to form reactants in the same reaction conditions. You can see here one example. Acetic acid reacts with ethyl alcohol to form ethyl acetate and water. And here the ethyl acetate and water again themselves react to form acetic acid and ethyl alcohol. So the reversibility you can show this shown with this symbol. This is the reversibility. The second is one category is irreversible reaction. That means opposite of this reversible reaction. That means when reactions happens and form products, the products cannot react themselves to form reactants again. That means reverse cannot be taken place. So the products formed are actually standard products, or what you can say is stable products. So the products here C, A and B is reacting to form C and D. And the C and D again cannot react themselves to form A and B back. This cannot happen in the irreversible reaction. The example for this one, methane gas reacts with oxygen to form carbon dioxide and water. So the water and carbon dioxide, even though are the same reaction conditions, cannot revert back, give the methane gas and oxygen. That is the irreversible reactions. So there are many other type of reactions categories are there, like elementary and non-elementary reactions based on the order, first order, second order reactions based on the rate of a reaction, that means speed of the reactions. We can have slow reactions and fast reactions, and similarly based on the number of reactions taking place, single reactions and multiple reactions are there. So these are we'll discuss in the further classes. The next topic is rate of reaction. The rate of reaction actually refers to the speed at which the reactants are transformed into products. So here the rate can be expressed based on the unit volume of fluid for homogeneous reactions, and based on the weight or surface area of the solid for heterogeneous reactions. Similarly, the rate can be expressed based on the disappearance of the reactant or based on the formation of the product. Take for example, the rate of disappearance of component I based on the volume of the fluid. Here we are taking the rate of disappearance as well as based on the volume of the fluid. So you can see the definition, minus Ri is equal to minus 1 by V dNi by dt. So this minus sign actually shows it is a rate of disappearance. Similarly, the 1 by V, this is a volume of fluid. So for homogeneous reactions, we normally define based on the volume of the fluid. So here you can see the moles of I disappeared by volume of the fluid and time. So that is the rate is defined. Similarly, coming to the rate of formation of the component, you can see the formation of component means you can see the positive sign here. So the difference between the disappearance and formation is negative sign. For disappearance, normally we will use negative sign, and for formation we will use positive sign. This is 1 by V dNi by dt. So volume of I formed here and by volume of fluid and time. We can able to define the rate of disappearance of the component I based on the mass of the solid in fluid-solid system. That means what you can say the heterogeneous systems. So for example, see here the minus Ri dash is actually based on the mass of solid. So instead of volume of fluid, here in heterogeneous reactions, we can take the mass of the solid as a reference or base. So 1 by W, which is W is called the mass of the solid, dNi by dt. So moles of I, so it is moles of I disappeared by mass of the solid into time. Similarly, you can able to define based on the surface area of the solid, that is S. So minus Ri double dash is equal to minus 1 by S dNi by dt, where S is the surface area of the solid. The third one, we can able to define the rate of disappearance of the component I based on the volume of the solid. Instead of volume of the fluid, as we defined earlier, we can able to define on the based on the volume of the solid also. So minus Ri triple dash is equal to minus 1 by Vs dni by dt. Okay. And coming to the, we can able to define the rate of disappearance based on the volume of the fluid also. So here the volume of the fluid means you can say the volume of the reactor. You can say VR. VR means volume of the reactor. Okay, volume of the reactor. So minus Ri 4 dashes is equal to minus 1 by VR volume of the reactor dni by dt. So you can able to relate all these different types of rates of reactions in one single reaction. You can see here volume of fluid into Ri is equal to mass of solid into Ri dash is equal to surface of the solid into Ri double dash is equal to volume of the solid into Ri triple dash is equal to volume of the reactor into R4 dashes. Okay, so this is the regarding the rate of the reaction. So coming to the next topic, that is variables affecting the rate of the reaction. So there are different variables out there can able to which will affect the rate of the reaction. The first one is nature of reactants. So the nature of reactants itself is a very important factor that affect the rate of a chemical reaction. For example, some reactants are very active, and they can react very fastly to form the products. For example, sodium reacts violently with cold water because they are very highly active. Similarly, calcium does not react with cold water at all. That means it is not active. Similarly, you can see in the classroom also some students are hyperactive. They can easily understand whatever the topic is told by the teacher. Okay, so some students are not that much active to absorb, to understand the concept of the lecture. The second important variable or factor is the concentration of reactants. So if you increase the concentration of reactants, what will happen? It increases the rate of a reaction. Why? Because in the increase of the concentration, more number of molecules will be there in this given volume. That means the collision chances are increasing more. When the collision chances are increasing more, the product is forming more. That means the rate of reaction is increasing. So when the concentration is increasing, you can see here the same given volume at higher concentration, more number of collisions can happen to form the product. That means the rate of reaction is increasing. So rate of reaction is increasing when the concentration is increasing. And third important factor is temperature. So as the temperature of the reactants increases, the rate of a chemical reaction is also increasing. This is because the kinetic energy of the reactant molecules are increasing, causing them to move very faster and colliding more often. So when you increase the kinetic energy, what will happen? When you increase the temperature, what will happen? The molecules gain more amount of kinetic energy so that they can move very fastly. And more often you can move here and there, and collisions also will increase very much more, and these collisions also will occur with much force, making them likely to form the product. That means what you can say, when you increase the temperature, what will happen? The molecules move very fastly because increase in kinetic energy. So when the molecules are move very fastly, the number of collisions are increasing to form the products. That is the third factor is temperature. Coming to the fourth factor, that is pressure. This is mainly used for the gas phase reactions, as we have seen in the concentration. Like here also, when the gas phase reactions, when the pressure increases, the number of molecules, you can see here the number of molecules in a given volume is increasing. That means the number of collisions are increasing. See, when the pressure increases means actually the volume will be decreasing less. That means the number of collision, the more number of molecules will be there in a given volume. That means automatically the number of collisions are increasing to form the products. So the rate of reaction increases when the pressure is increasing. The fifth factor is the presence of catalyst. So as already told, the catalyst is actually increases the rate of the reaction without being consumed in the reaction. So if the catalyst is there, what will happen means it lowers the activation energy. So you can see here it lowers the activation energy. That means more reactant molecules can able to react and form the products. So when the activation energy is less means more reactants are there to react themselves to form the product. That means the rate of reaction increases in presence of catalyst. So basically the catalyst decreases the activation energy required. Okay. The sixth important factor is the surface area of the solid reactant. When increasing surface area of the reactant, what will happen? It exposes more particles for the other reactants. So if you have a solid reactant is there, when the surface area is increasing, you can see here this is the solid phase, and because surface area is limited here, very less number of collisions are happening here. If you increase the surface area by breaking this solid into some pieces, there are more chances of formation of the more product. That means increasing surface area increases the interaction between the molecules, or you can say the collisions, so that the rate of reaction increases. So the rate of reaction increases when the surface area of the solid is increasing. Okay.
Like, share and subscribe. Hit the bell icon for more updates.